Hello there, I am Dr. C.N. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Thank you for joining me once again on this channel. I want to encourage you that before you go too far in looking at this video, you should have looked at the intro to regression analysis, because what I'm going to be explaining in this video is very much anchored on what I had explained in the intro video. So please go back, look at it, and then come back to this video and so you can connect with what we are discussing. Today we are going to look at one example of regression analysis, and that is a situation where we are given values in a distribution where we have values for x and y, and we are going to predict what y will be should we have x, and what x will be should we have y. That's what we're going to look at today. Let's look at what we have on the board. Thank you for joining me. We have here we need to compute the two regression equations from the following data. We're given x and y. X is having a consistent rise from 1 to 8, and then y is having 2, 3, 5, 4, and the rest like that. Now the question is, after we've computed the regression equation, we're now asked that if x is 10, what will be y? That's the question we're asking. So you see, we do not have 10 extended here. So we're trying to assume that from the regression equation we're going to have, if x becomes 10, what will be y? How about if x is 15, what will be y? That's the question we're asking. That's on one part. Then the other part is, if y is say 17, we stopped at 13 here, so to say. So if y were 17, what will be x? So x will be what? That's the question. Now if y were 20, what will be x? That's what we're asking from this question. So let's solve this question. Let's solve this question with me. The first thing we do is to write out our regression equation, what we need to find out. First of all, we want to find y. Y is equal to y bar, this is y bar, plus the slope of y based on x, all into x minus x bar. Don't worry, we're going to define these values where y bar is mean of y, x bar is mean of x, and the beta, or the slope, is given as summation of x and y all over summation of x squared. All right, and if we want to find x where y is given, so the regression equation will be given as x is equal to x bar plus b y x y, as we have b x on y, then we have y minus y bar. So where these values are the same, the only thing will change is b x on y is going to be summation of xy all over summation of y squared. Now, let's now represent this in a table. All right, so we are going to now prepare a table to determine these values, and then we solve and determine to find the regression equation. Remember, the question we're asked is to find or compute the two regression equation. So what we do first of all is to find the mean of x. Remember, the mean of x will be summation of x all over n. Summation of x all over n. In this case, we add all these values. Let's say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 equals to, divided by 8 number. So if we sum all that, 1 plus 2 plus 3 plus 4, what we're going to have is 36. 36 divided by 8 will give us 4.5. So we already have the mean of x to be 4.5. We can also find the mean of y, that's y bar, which will give us summation of y all over n. And that will be 2 plus 3 plus 5 plus 4 plus 6 plus 9 plus 12 plus 13 divided by 8 also. Can you quickly add this up? When you add this up, what you should have should be 54.8. So our answer there is 6.75. So we now have the values for x bar and y bar. What are we going to do with x bar and y bar in relation to this? We want to now draw a table where we'll find what we need to use to determine our regression equation. What we now do, we have our values for x here like this. Draw this down, and then our values for y. So let me write 1, 2, 3, 4, 5, 6, 7, and 8. And then y is given as 2, 3, 5, 4, 6, 9, 12, and 13. Now, we want to find the deviation of x. The deviation for x will be represented by small x. Small x is x minus x bar. The small x we are going to have is x minus x bar. So will be all these values minus 4.5. This is 4.5 here. Okay, so this is x, which is the deviation, minus this x minus x bar. That will be our value for x. So let's quickly do that. 1 minus 4.5, that will give us minus 3.5. 2 minus 4.5 will give us minus 2.5. 3 minus 4.5 will give us minus 1.5. 4 minus 4.5 will give us minus 0.5. Sorry, this is minus 0.5. 5 minus 4.5 will give us 0.5, that's positive, and this one will give us 1.5. 7 minus 4.5 will give us 2.5. 8 minus 4.5 will give us 3.5. Okay, that's what we have. Also, let's find y. Small y will be y minus y bar, as we have. So this is y minus y bar. This is the mean of y. And the first one, 2 minus 6.75, will give us minus 4.75. The next one will give us minus 3.75. The next one will give us minus 1.75. The next one will give us minus 2.75. 6 minus 6.75 will give us minus 0.75. 9 minus 6.75 will give us 2.25. The next one will be 5.25. And then 8 minus, beg your pardon, 13 minus 6.75 will give us 6.25. All right, so remember, this is y, the values of y minus y bar is giving us a small y. Okay, so what we do, remember what we did during when we're working on correlation, what we did with our x and y. So we're going to have x, y, that's small x times small y here, and we're going to multiply these values times these values. So what we have, if we do it as we have here in our solution, we have 16.625. The next one will be 9.375. That is, we're multiplying these x values by these y values. Okay, so the next one is 2.625. The next one is 1.375. The next one is 0.345. The next one is 3.375. The next one is 13.125. And then the last one, these values, 3.5 times 6.25 is giving us 21.875. All right, after we've done this, we now find x squared. This is x squared. Remember, we're going to use x squared here. Look at what we have on our board. We're going to summation of small x, summation of small product of small x and y all over summation of x squared to get our slope, to get the rate of change. Also, we're going to use the summation of x and y here all over summation of y squared to get, that's why we're doing this. That's why we're doing this. Let's go back to what we're doing. So x, that is the square of our x values. The square of our x values will give us 12.25, that is minus 3.5 squared. Remember, in your calculator, to get this value, to get these values that have negative, what you do is to put your minus 3.5 in a bracket. If you do this and you now put exponential 2, you will get positive. But if you do not put it in a bracket, your answer will be negative. Don't forget that. The answer will be negative. Let's continue. The next one will be, what you should have will be 6.25. The next one will be 2.25. The next one will be 0.25. The next one will be 0.25. Okay. All right. So the next one is 2.25. The next one is 6.25. And the last but not the least is 12.25. Okay. Then lastly, we'll check out the small y squared. We'll do our small y squared, and that is these values here on this column. We will bring them here. Let me move to this side of the board so that we can have a better view of what we're doing. So this is going to be the first one, that is square of minus 4.75. The square of it will give us 22.56. I've rounded off that. So the next one is 14.06. The next one is 3.06. The next one is 7.56. The next one is 0.56. Okay, I trust you are following me wherever you are. Do it very quickly. The next one is 5.56. 0.06. The next one is 27.56, and then we have 39.06. That's what we have. What we now do is that we have to sum. We have to sum all these values we have on our table. So right here, not convenient for me here, I will draw my line and put the summation sign. So we already know that the sum of this is 36, as we did up there, and then the sum of this is 54. That's what we use to determine our mean, the mean of x and y. If you sum this will result in 0, so there's no need. So let's sum this one. Let's sum x and y. X and y will give us 68.75. Then sum of x squared will give us 41.75. And sum of y squared will give us 119.48. So 119.48. So this is what we have to deal with. So the question now, what do we do with all this? Now this is where we bring this to play. This is where we now have to we want to determine the regression equation. That we want to determine what the regression equation will be, in that we want to determine y based on the value of x. So let's repeat this here, this equation. Let's repeat it up here on our board. Can you follow me, please? So we have y is equal to y bar plus b y based on x, and we have x minus x bar. Okay, so what do we do with this? Now to get this one, we have to, we know all these other ones. We know what y bar is, we know what x bar is, we're looking for x, but we now need to determine this one, the slope. The slope, as we can see on the board on that side, it's given as by based on x is the summation of xy all over summation of x squared. Summation, please zoom this closer so that our viewers can see. So we have this. Now, what is summation xy? Here was xy from our table gives us 68.75 divided by summation of y squared. Look at summation of y squared. We have 41.75. So what will be our slope based on that? That is 68.75 divided by 41.75. What we're going to have should be 1.65. So 1.65. So based on what we have this value, which is this, we have this, we have this. So let's find what y will be. Y will now be y bar. Look at y bar here. Can you see y bar? Y bar is here. Is 6.75 plus 1.65 times x minus x bar. X bar, which is our mean of x, is 4.5. Let's open up this. This becomes 6.75 plus 1 times 1.65x minus 1.6 times 4.5. What are we going to have? We're going to have 7.425. That's what we have. Now, collect like terms together and pull them together. So if this meets up with this, 6.75 minus 7.425, we are going to have a negative, so that it becomes minus 0.675 plus 1.65x. So this is the regression equation. This is the regression equation we have determined. And our question is that if x is 10, what will y be? These are regression equations. This is what we've been looking for all day. All right. So let's now put x where we have, why not put 10 where we have x? What will y be? That's what we want to predict. So y will now be, y is equal to minus 0.675 plus 1.65 times 10. And what will that give us? This will give us minus 0.675 plus, this will give us, if we multiply through by 10, it will give us 1, that will give us, this will give us, all right, this should be 16.5. So if we have 16.5 with this minus 0.675, 16.5, this will give us 15.875, approximately 16. So it means that if x is 10, if x is 10 here, y will be 16. So we are, that's what regression does. The second one is that if x were 15, let's solve that. If x were 15, we have minus 0.675 plus 1.65 times 15. Okay, this gives us 0.675 plus 1.675 times 15. That gives us 24.75. We have minus, this now give us what? This should give us 24.075. So this gives 0.75. So approximately 24. So if x, okay, so this is actually 24.075. So approximately is 24. So if that means if we extend x here to 15, then y is 24. Now, from what we've done so far, we've been able to determine the regression equation for predicting y on the basis of x. So we can quickly, let's see what we can do with this space we have. So for x, the other one, we have x is equal to x bar plus our beta, that's beta x based on y. Then we have y minus y bar. So based on what we have, to get our beta, that is the rate of change, xy is going to be summation of xy all over summation of y squared. All right. So what is summation of xy is 68.75 divided by summation y squared. So we have divided by 119.48. So our beta there, our beta value will be what? Will be 0.58. So that means that if we want to predict x, it will now be x is equal to x bar, this is 4.5 plus 0.58 into y, we're looking for y, minus y bar, the mean of y, that's y bar, that's minus 6.75. Okay, if we multiply this through, we have 4.5 plus 0.58y minus 0.58 multiplied by 6.75. What do we have? We're going to have 3.92. So if this and this come together, our answer will be 0.58 plus 0.58y. So this is how we can predict x. So I'll leave you with finding out what x will be if y was 17. If y was 17, what will x will be? So all you do is to work out, can we manage this somewhere, somehow? Is to work out what it will be if y was 17. So there will be 0.58 plus 0.58 times 17. And for my solution here, you are going to have 10.44, which is approximately 10. Please, I will want to advise you to go through this video again, go through all the steps that we've gone through. We've been able to determine the first regression equation, and then this is the second regression equation that we have found out based on the distribution that we are given. Thank you very much for joining me on this channel. I await comments in the comment section, as well as making sure that you subscribe to this channel. God bless you.